Okay, so now we really heard a very exciting presentation from DKM regarding the cell materials. Now just move into the module materials. And probably if you have heard in one of our previous conference for TOPCon, I think BOM is really important when it comes to the reliability. I think Lars has shown his research in previous conference where he made some tests and he saw some modules were really passed all the tests, some of the TOPCon glass backsheet, and then some did not. And he simply said, BOM is the key. So that's why we have invited one of the actually world's leading encapsulant supplier, Hangzhou first. We have Hou Hongbing, who will be talking about addressing the moisture sensitivity and specific needs of TOPCon modules with new encapsulation materials. Hongbing is a technical director at Hangzhou First. So the floor is yours. Oh.
Hi, Shaban. Yeah. Can you hear me?
Yes.
Okay, I will share my screen. So all is perfect with my screen, right?
Yes. You might have to go into the presentation mode. Yeah.
Okay. Good morning, everyone. Yeah, thanks for your time. Yeah, I'm going to share, my topic, innovations in encapsulation materials for TOPCon from module side. So here is a brief introduction about Hangzhou First. Hangzhou First is an encapsulant and a backsheet supplier in the world. And it keeps the #1 supplier in the world for 10 years for encapsulant. And for backsheet, Hangzhou First is the #2 supplier in the world. Now we have 4 production bases in China. The total capacity is 270 gigawatts. And we have 2 production bases overseas in Thailand and Vietnam. So our annual production capacity is 300 gigawatts for encapsulants and 50 gigawatts for backsheets. Production base is in Vietnam and China. So now let's move to the encapsulation solution for TOPCon. So in the past 2 or 3 years, we are happily seeing the development of TOPCon, no matter from efficiency, but also from capacity and production. And we think this is the main technology over the next 3 years. But also, we also see some, challenges. We can say degradations of TOPCon cells. There are mainly two types of degradation. The first one, model 1, is a moisture-induced degradation. This mainly happens to glass backsheet modules. And model 2 is a PID problem. Yeah, this is for glass and glass backsheet. So a good encapsulator film can help solve these problems. So my part 1 is about encapsulation for double glass modules using TOPCon cells. This is a very matured encapsulation solution in the market. For double glass modules, module manufacturers can use both side EPE product or from the EPE backside EVA to encapsulate the modules. And no matter from PID test or DMP test, all shows a very good result. The power loss of double glass module is less than 5% after PID 480 hours or DMP 3000 hours. So EPE product is widely applied in TOPCon glass modules, but the thickness of POE layer in this EPE product is very important. It has a significant impact on the anti-PID performance. You can find out from the market the thickness control capability in the market is totally different between different suppliers. And here is the table for different POE layer thickness, the influence on PID. This we take the example for PEPE cells. Yeah. And this slide is shows for TOPCon cells. So ultra thin POE layer in EPE film will come out. We can find out from this unit weight of different POE film in the EPE from 90 grams to 150 grams, all shows a very good PID property. So EPE with ultra thin film layer exhibits excellent PID resistance. The power loss is less than 1.5% for both the front and the rear side after PID 96 hours, and the power loss is less than 2.5% after PID 288 hours. So glass is very matured in the market, and we have challenges on glass backsheet with TOPCon cells. We did a comparison, after PCT tests on glass backsheet modules encapsulated by different film sets, both side EVA, both side POE, and both side EPE, and we found out all these films are with corrosion problems. The corrosion rate is EVA is very similar to EPE, and POE is the lowest one. But we also find out even POE film yields a significant risk of corrosion in glass backsheet TOPCon modules. So here we are trying to explain the mechanism of these problems. With glass backsheet modules, there is oxygen, the water, moisture, salt comes from the backside backsheet, and from the front we have vanadium, cadmium, ions come from glass. And for encapsulant itself, it has many different additives. So all these matters, they form an electrolyte environment. We call it salt bridge. So Hangzhou first developed a new type of POE we call TF4N, to block this problem. So we can find a TF4N with a very good blocking ions mutability. This is the main mechanism of this new POE. Compared with traditional EVA, EPE, and the POE, TF4N shows a very good property after PCT 192 hours. And when TF4N, this new kind of POE, is applied on the front side, actually the rear side, the rear film slightly affects the modules. But we also find out for the rear film, our new kind of EVA, we call it EPE+, a D-acid EVA is better than common EVA. So this EPE+ EVA is a new generation EVA of acid resistance. And we cooperated with Japanese company Kyocera. Yeah. This is a test, a PCT test. Yeah. It shows, this EVA can better prevent the solar cell corrosion compared to common EVA. Also, when TF4N, this new kind of POE is used for TOPCon, WVTR or backsheet slightly affects the module. This is a hot topic in the market. Customers are trying to find low WVTR for TOPCon modules, but when the TF4N is applied, even CPC backsheet can be used. So our viewpoint, from the perspective of cost and reliability, there are two encapsulation solutions for glass-backsheet modules with TOPCon cells. The first one is use front TF4N, this new type of POE, and the backside use white EVA with normal white CPC backsheet. And the second option is to use front TF4N new type POE with our D-acid abyssal EVA. This is transparent EVA. Go together with black CPC or transparent CPC backsheet. And with this two bomb, we did the PCT test and a demo heat test. And we can find out both of the bomb can pass 2 times the IEC standard. And the TOPCon glass-backsheet modules exhibit both PID and MID. When TF4N is used as a front film, and there are no black spots on the modules after PID. So here is a brief summary about this presentation. The double glass modules of TOPCon mainly affected by the PID on the front side. So the encapsulation type can be front EPE and a backside EVA. The glass backsheet modules of TOPCon mainly is affected by the PID and MID. We can use front film of TF4N, while the rear side can utilize different options. But we do see abyssal low acid EVA is better than common EVA. Number 3, the WVTR backsheet slightly affects the glass backsheet modules when TF4N is applied for the front. In this way, the CPC backsheet can be used. As you know, Hangzhou First is the number 2 backsheet supplier in the world. So, when TOPCon can use a normal kind of backsheet, it is suggested with Hangzhou First high reflectivity black backsheet. This HR black backsheet is a non-metallic pigment system. It can reflect both the gap infrared light and the transmitted light, promoting efficiency. We can find out traditional black backsheet with almost no reflection, while the white backsheet have a high reflection. So our HR black backsheet is in the middle. That's all. Thank you.
Okay. Thank you very much for this presentation. And are these products currently available commercially?
Yes, all these product is sold out. Is sold to the market for more than for around 1 year. The TF4N, the D-acid EV actually, we sell this product to the market for many years.
And so are there any special processes that are required at the lamination? So how does the lamination process is going to be affected with the new films? So now you have proposed 2 one different, two different bombs, right? So how is it going to affect the lamination process?
For lamination process, it is same as the previous. These two materials are widely used in the past for poke. So this is just a POE with EVA lamination. So there is no difference, compared with previous one. Yeah. So yeah,
Okay.
customers don't need to be worried about that. Yeah.
Okay. So thanks a lot for this insightful talk about the encapsulations and backsheets. There are also some questions about the basics, like why EV, why PIVO, why EPE, why not PIVO-E. So it would be great if you can answer these questions in the chat while enjoying our conference.
Okay. Yeah. Well.